Hey everybody, back with another pole position video.
Alright, next day, still messing with this, and you can see that the cars like disappear when they're trying to go from the small cars, like it's the distance thing, but they then appear when they appear close. Might have multiple issues going on. Something with the transition from far to near, or small cars to big cars, and we got issues on the signs. Issues with the cars until they get up real close, and then there's still issues with them. So it said basically check 13H, 11H, and 12H, if I'm not mistaken, or 13N and 12N. But it was kind of insinuating the guide anyway, not the guide, but the user manual was insinuating checking this area. So I just did the easy thing. I pulled this prom, I tested it, it verifies correctly, even though they removed it and the legs are kind of weird. I don't like that, but that's not the problem. I swapped out 13H, that didn't change anything. I swapped out 11N, I swapped out both 13N, 12N. I swapped out all these ROMs just because I have an extra board, so might as well eliminate the things that I can to swap out parts. Then I came to look at the schematic here, and I was really just checking to make sure, like, these are the ROMs and stuff. Making sure I just like had all my outputs were working. Like this, I had activity on this LS139. I had output here on this LS74 10B. I had, activity here on 11J. And I come all the way through, the ROMs, and then 11H and 13H, and then the prom at 12H, I think, right? Yeah, that's the prom right there. And it comes out to these four signals here, MP4, MP3, MP2, MP1. That goes to the next page called Video PCP, horizontal address counters, and motion object buffers. So these are the two portions that I think that we might have a problem on, but I'm not sure. We're just kind of working our way through the video section. And then I started checking all these, and the LS158 looked good. By the way, I couldn't go to sleep last night. I had to keep screwing with this thing. I was doing all this last night, catching you up. I'm looking at all this, and it kind of looks okay. I mean, there's activity on all the RAM. Tried piggybacking a RAM, a 2148 actually, and I didn't see any noticeable change there. Then I think I was looking at the inputs, and I think the inputs are working, but I'm going to start focusing on this area here, these LS161s at 9H, 9K, 10K. And kind of look at those and maybe even put my logic comparator on that. The last thing I'll say is, before I start programming around again, is I did replace the 163s with the LS163s with HCT 163s. So an LS is around 30 nanoseconds, the HCT is around 10 to 12. Not quite as fast as an S chip, but I bet I'm not noticing any issues. I doubt that's my issue. So yeah, so let me get the logic comparator out and let's start probing around like 10J, 10H, all these 161s here. 161, 161, 161, all of these suckers. Let me hook up my comparator, see if any of those are bad, because that's pretty easy. My comparator on there, and unfortunately, I don't think it's going to be a good test. I mean, it shows as bad, but these are S161s. Here, I'll just show you there. Oh, actually, the game's not even running. Or did it coin up or something? Let's see. It might have some other issues going on. It's kind of flaking out a little bit. Yeah, you see, it's okay. It's running. I got errors. If I go to these 161s, like almost all of them show bad. So I don't think the comparator is going to be a great way to to show this. There's another one that shows bad. I'm going to try to come up here. Now that one looks kind of good. 10L. But it really only has 2 outputs being used. It has less inputs. I mean, I don't know. That one doesn't look as good or as bad, I guess, depending on how you look at it. I just reset the game. But yeah, so anyway, I don't think the comparator, I'm going to have to get my scope out and then probe all of these 161s and just see, hopefully something jumps out at me. Because then it comes to these MO's motion object. That's a motion object out, and I have activity there, but obviously it's not right. And then that comes to here where it gets like muxed in with pick 4, pick 3, pick 2, pick 1, which is probably some other image, and then you got the character lines up here, and all those are kind of getting combined and muxed together, ultimately going to the color proms probably. And then the color proms, because there's red, like I went before, there's red, green, and blue or whatever. So all of these lines go into their color proms and then get amplified and sent out. So I don't know. I'm hoping it's got to be one of these 161s. Most of everything else looks okay. Otherwise, I'm gonna have to shotgun these RAM, I guess. All right, I put my working board on because I wanted to, probe some of these signals, some of these 161s, and the size enable signal and stuff like that. But watch this right here. I'm going to probe this size enable pin, 8E pin 3. 8E pin 3, 1, 2, 3. And watch how it changes on my scope based off of what's going on the screen. Like you can see where the signs go past, and then there's getting an explosion, and then I don't know if it's correlating or not. It seems kind of strange, right? We'll watch it go through a track real quick. See how the sign just went by, and when cars go by, like stuff's happening when the cars get closer and then further away. For some reason, I just suspected the size enable, I don't know, because it's changing when the cars are different sizes. Like it looks like, see, okay, we got probably 2 different issues going on, but look how it changes when they get further away, and then they get closer and they get further away. I don't know, it just seemed like I didn't really guess it was the size enable, but I was just like, let me probe it. I'm glad I did probe it on the working board. 8E pin 3 right there. Look at the difference. I mean, that thing is not even getting up to 5 volts. It's really doesn't look anywhere near the same. Do I have it on times 10? Hopefully I didn't screw something up. Let me try it again. 8E pin 3. Yeah. Yep. I mean, it's not right. That size enable thing is jacked up. And so where does that come from? Let's see here. Let me pause. I don't know where it comes from. This section, the size clock rate generator. 9K. I haven't even started probing it yet. Let's check it out. 9K. I don't even know what a 7497 is. 9K. Okay, it's right here. Interesting. It's got some, from the washing, there's a little bit of flaking on the legs and stuff like that. I don't know. That's kind of interesting. pin 5 is the output. 1, 2, 3, 4, 5. And that's what we're getting, which does not look right. But let's check all the inputs. So pins 2 and 3 and 4. 1, 2, 3, and 4. There's 1, that looks good. 2, 3. Yep. I mean, I'm just looking to see if the signal looks somewhat decent, like getting high and low. 1, 2, 3, 4, 6. 6. Well, let me wait till the screen does something different. But that looks kind of weird. Okay, 6 isn't an input. I must have read that wrong. 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, and 15, I think. I see something there, but I don't know, that looks kind of weird. That's pin 15. Alright, there we go. Nothing's going on pin 13. That leads us to, so pin 13, nothing's going on there. Now, I don't know if there should be something going on, or if it's just always low. I mean, because it could be more of a static thing. I'm not sure. 7C, pin 5. 7C. 1, 2, 3, 4, 5. 1, 2, 5. Yeah, there's some activity going on that pin 5. And the output is pin 6. Kind of difficult to see. Seven C and 5. 1, 2, 3, 4, 5. Adjust my intensity. Speed it up a little bit. And you still can't barely see it. It's definitely going down. And 6 is the inverted of that, but it doesn't look like it's going all the way up. I'm wondering if this 7C 74SO4, I wonder if something's jacked up with that. I'm going to probe a little bit off camera to see if I can. Went to the logic probe here. 7C pin 5, and then it gets inverted on 6. And it sounds like it's, the same pace and everything. Like, it changes, but I mean, it sounds like it's okay. But if I go back to our 9K, which is that size enable, 9K, pin 5, 1, 2, 3, 4, 5. That is not good. And let's just check our enable here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is column address select. I wonder if that should be toggling or something. No, it's probably pulled high with the resistor, so that's probably always high. Clock is pin 9. And the rest of the pins are working. Like pin 4, yep. Pin 5 is dead. I don't know what pin 6 is. It's probably not doing anything. Pin 6 and 7 aren't doing anything. I don't know. That chip seems suspect to me. 9K. I doubt I have one of those. 7497. Let me see. All right, I piggybacked the 7497 on there, and it's we got improvement, right? I'm pretty sure, yeah. We still have some lines going through stuff, but I'm pretty sure that's better. Let me see. What was that enable was going to 8E pin 3. 8E pin 3. Yeah, it's toggling now. And you can see how it changes as the cards get closer. Listen to it a little bit. See? Alright, I need to socket that or replace it. Actually, I don't have any sockets, so I'll just replace it. Okay, got the 7497 at 9K replaced, and I was just looking because I was swapping the other ROMs back in, and look at 13K. I missed a leg again, but these are the original ROMs. I put the original ROMs back in there because I tested them in my other video board. I tested all these chips and they all work fine. But when I was putting it back in, obviously that was messed up. But regardless, our 9K, I think, was our biggest issue. See what it looks like. So we still have some lines going through, like the signs and the cars and stuff, but much better as you go from far to near. You can see that we don't have like completely missing objects and sprites and stuff like that. So that was definitely that size enable signal that was causing that behavior we were seeing before. So let me go ahead and fix 13K and see if, I don't know if that's going to fix our lines or not, but okay, 13K we'll is fixed. Let's see what our sprites look like now. Alright, that wasn't it. It still looks a little jacked up. Still some lines going through. Now this could be RAM, potentially. I might try piggybacking some RAM just on these 2149s or 21 with. I have 2148s actually, or replacements at 10F and 9F. I don't know if that's the issue, but just based off of reading, that might be the issue. Otherwise, I'm actually curious to see if I could do signature analysis. All of your signals for your like 128V, 256H, all that stuff, 64H, your horizontal and vertical counters are from this 2F. And I'm kind of curious to try to see if I hook up my signature analysis, how far I can go, knowing if I have good signals there, like how far I can go through the video portions of this bus. I mean, the video address bus and everything that gets enabled and crap on the from the video address bus or vertical, the counters and stuff. So I'm curious about it. I don't know if I'll do it in this video. We'll see. All right, I figured I would try the signature analysis. I could just shotgun these two RAM here at 9F and 10F, but I'm honestly kind of interested to see how far signature analysis on the counter chain can get you. And the way Pole Position is set up, and I've just been doing some experimenting off camera, I think it can get us pretty far. We could probably test a lot of components with signature analysis. So I started looking at where do I want to hook up the signature analysis, and on the video board, as we fixed our own clock circuit, we kind of covered that earlier in the video. The main chip right here from our crystal is this 163 at 7B, and that basically creates your 12 megahertz 6 megahertz clock. Now the schematic doesn't really show where that 6 megahertz goes, but it actually goes to 7C, which is a 7404, I believe, an inverter. Gets inverted there, then comes to 6B. I'm talking about the 6 megahertz right now. Gets inverted again at 6B, because you can see here's 6B on the video sync chain. So 6 megahertz comes in, that goes to pin 7, which is basically, so it's double inverted, so it's back to being really the original 6 megahertz, I think. And then that comes into pin 1, and I looked up on, there's a data sheet for customs on, you can look up what the Namco custom pin out is, because it wasn't obvious like which pin out was clock and which were the inputs and outputs and stuff like that. But pin 1 is the clock. And on any counter chain, you can basically even test this LS163 just by hooking up on your clock on pin 2 and your start and stop on pin 11, and you can get standard signatures on a 163 and 161 and test them that way. So if we look at this custom, I know this is long-winded, but I'm just trying to explain my thought process. If you look at this custom, if we put our clock on pin 1 and we look at, you know, our entire counter chain, our sync chain basically, and we go to pin 20 as our most significant, so we put our start and stop on pin 20 and our clock on pin 1, we're basically should be getting every single part of the video address bus, like, you know, from 1V, I mean 256H all the way to 1V, to 128V, as an example. That's my theory, and it's not going to work for everything because not everything is being addressed by this, and there's other kind of crap going on. But that's where I'm hooking up. Start and stop on pin 1, or you could actually come right to the clock. You could get your clock straight from the 6 megahertz, then it gets inverted, then it gets inverted again, comes over to pin 1 at 2F. So you can go to pin 1, or you should be able to go just to 6 megahertz pull up right here, or I mean test point, as an example. And then with that, I mean, I think we're going to be able to test, like, we'll definitely be able to test these vertical position proms, which are down here. We'll be able to test those with signature analysis. I mean, we should be able to get all of these vertical address buffer outputs. And I even came to the 161s, which are, you know, addressing the RAM that is in question, and we can get signatures on all of those as well. So that's super beneficial. So I'm going to put my working board on here. I'm going to record a bunch of signatures. I don't know how much I'll document, and then I'll come back when I find something that's interesting. This is my working video board. All you really need is power. I don't even have this connected to the CPU board. I'm just going to power it up, and all we need is a good clock signal. And this is the minimum pretty much that we need to get working. So like, have your LS163 working. If that's working, then you can pretty much, and with that working, you can definitely verify that your counter chain is working. I'm not going to do all that in this video, but you can. And then if your counter chain is working, we can use 2F to pretty much do signature analysis on most of the video address bus that the video address bus touches, like enables, outputs, and, you know, all types of stuff. Alright, so we're going to hook up our, this is my 55 HP 5005A. I actually have a 5005B, but there's something wrong with my probe, I think, on it. So this one, I actually did a video, I'll link to it. I did a video on repairing this. Very proud of myself for doing that, because I like it. But we should be able to use the Catbox FPGA to do the signature analysis as well. I just felt like using this for the time being because I didn't want to roll out the computer all the way over here. So our clock, again, like I mentioned, will go on pin 1 of 2F. And if we wanted to, we could just come all the way over here to this 6 megahertz. If you can see that right there. That should work, but I'm going to do it this way. Damn, sorry, you can't really see what the hell I'm doing. There we go. And then our start and stop, we want to come to pin 20. I think this is 14, yeah, 15, 16, 17, 18, 19, 20, which is, what is 20? I can't remember now. 128V, I think that's right. All right, with that set up, we'll just power it on. We have our gate flashing. We'll take our ground measurement, verify it's 0, take our plus 5 volts, 4577. If I come to pin 1, you get 0, 0, 0, but now if I go through my counter chain, you can see stable signatures. That's pin 2 of my counter chain. And what is pin 2? No, I don't have the right damn thing up. Alright. Pin 2, it's that's probably 4H, 2H, 1H. I bet that's 1H. I bet pin 2 is 1H. It doesn't actually say it, but is that what I got before? I'm pretty sure. We're going to do some testing here. So, I'm going to record these signatures. I'm just going up the counter chain here. And we're getting stable signatures, you see? And if I come all the way to 10J, pin 11, see how we have stable signatures there? That means we should be able to verify, like take the signatures on this board. Actually, what I'll do is I'll just record the 161s, like 10H, 10J, 10K, 10L, 9H, 9J. Record all those, and then put my non-working board back on and see if it truly is, you know, something that we can compare. If they're different, then maybe there's something wrong actually feeding the stuff. But I have a couple working boards. We'll be able to figure it out. I have my non-working video board, or the one with the glitch, and I did all the signatures on my working board for these 161s, and it doesn't look good, like they're going to match up. And it could be because of some data bus stuff going on, and you know, maybe these are driven by some ROMs or something. I don't know, and the ROMs might be different. That doesn't make sense, does it? I don't know. Anyway, I did test all of these in the vertical position, all these B-proms here on the like 2B, 2C, 2D, and 2B, yeah. All of those test fine. And I was coming to actually part of the PCB sync chain, and I get a different measurement for this RHP. I think it's not Ripple, is it? Something chip enable, R, I don't know. Who knows what that stands for? But I get something different on chip 2H, pin 11. I get 589U, and I wrote down 5894. So I need to put my working board back on, because I could have just wrote that down wrong. But this should be consistent, because this is directly coming off of the counter chain, so I know that this should be good. But as you get further down, there's a whole bunch of different signals and stuff coming on. Like I got my motion vertical position, MVP. Those are fine, but then this is being kind of like not muxed, because I forget what a 283 is. It's like a 4-bit something another. I don't know. It's doing something combining those, some binary type of thing. What's it called? Oh, I closed my book. Whatever. But see, the data bus is disconnected from the CPU board, so there really shouldn't be anything coming from here. So actually, let me check 5D pin 2. Yeah, that's just high, because see, all the data bus, the DB line, data buffer 1, 2, 3, those are all high because it's completely disconnected from the CPU board. So therefore all those VSH8s are high. 4577 is my signature for my plus 5 volts, for example. See, I'm touching my plus 5 volts on my capacitor. That's 4577. Sorry for moving the camera around. I'm looking at this LS175 5H VSH, whatever that is. Let's look at pin 14 of 5H. I bet it's high. 5H. Okay, 5H right here, pin 14 should be right there. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that should be pin 14. I wonder why it's high. No, it's low, I mean, which is weird. What's pin 13? Yeah, pin 13 is high. I have to look at what a 175 is versus a 174, I guess. Regardless, all of these are either going to be always high or always low, I assume. Anything coming from these data buffers. So then the only thing we should be getting on these address buffer lines, like on 4C pin 3, 4C pin 3, it should be pretty consistent, I would think. 099P. I'm going to write that down. 099P. 099P. And then I'm going to check, I'm going to put my working board on and see what I see. Alright, well that was a rabbit hole to go down. So I will link to a thread on KLOV that I started talking about the signature analysis. Yes, I was able to get good signatures with my setup on the this 11A sheet, and like load, RCE, RHP, all these signatures you can get standard. I didn't take some of these signatures, but I wrote down most of them, which is good, right? I mean, and then I was able to get good signatures on the vertical position modifiers. I think I might have mentioned that in the video. So those are consistent. These MVP signals are consistent. And then you get to this vertical position buffer address, and thanks to, I can't remember his name, but he's in Australia, I think. Addr, OZ2 or something. I don't know. Something like that. These are flip-flops, and the LS175 is a 2 output, like it has complementary outputs. There's one that's inverted and one that's not inverted. So this VSH 0, 1, and 2 are all inverted from their inputs, and the LS174s are non-inverted, and they have a single output, for example. But anyway, I could get these to all be low based off of all the data lines being high, because they're pulled high while the PCB is disconnected. So that was good. He told me how to do that. Just clear, ground clear for a quick second, and that will set all of these to low consistently. So once you do that, then the MVP signals flow through this binary full address, I don't know, counter something another, 4-bit binary full address something another. These LS283s, I don't really get it what they're doing, but the MVP signals basically flow through that once you get all of these low, and then you can actually ground RCE and continue to get those MVPs flowing all the way through. Or, as I documented in the thread, if you go there, you could clock off this RCE and get signatures. But that's really as far as I could get. Like, there wasn't any way to get more consistent signatures or get further through the board easily anyway. So my best bet, this is my working board, but my best bet is probably to go ahead and remove
in shotgun 9F and 10F. I tried piggybacking. That didn't show any results, so I have my doubts that those RAM are bad, but that's really the only thing I've researched for lines going through would be that. So I don't know. I might probe around some more or not. I'm not sure. But the signature analysis, definitely a rabbit hole. It definitely helped and helped me understand the schematic. But there's so much going on with the customs at like 7E and 4D, and you know, there's stuff coming from the Z8002s from a data buffer stuff that's creating different signals and all types of crap that eventually flows into these and accesses the RAM. I don't know. I don't think there's any easy way to systematically go through it, but if somebody tells me there is, I'm all ears. Alright, I'm probing around this horizontal address counters, and remember, we had the size enable was wrong. Some of these 158s don't look, the 158s and even the 257s, I don't know, something's suspicious about it. So I'm going to look at 8E, which is right here, 8E pin 4. You see how it's not getting up to 5 volts. I mean, that looks suspicious. That's pin 7. That's pin 9, which looks much better. And then was it 10, 12, right? And pin 12 looks better. And this other 158 doesn't look great either. I don't know. I might put my logic comparator on it, or yeah, let's put a logic comparator on it. See what it looks like. I don't have any 158, so I put a working board on 8E pin 4. Looks basically the same. You know, it doesn't get very high or low. It's about 2 volts, 2 point something volts, which is, and that's on a working board. So I guess it's probably not those 158s. I'm gonna go ahead and probably shotgun the 2148s. I got nothing else better to do. Alright, I just replaced the 2148s. I have no idea. I've read that that could be the problem, but we will find out. Or maybe not. I don't have my monitor on. Man, that's not the problem. Oh shit, that sucks. Because I have no idea what those lines are. That blows. I'm stuck. I've looked all over that area. I might have spoke too soon. I don't know. I didn't do anything. It's just like it was powering up and problem fixed. I mean, I kind of was just like sitting here pressing on them off camera like for 2 seconds. I literally was 2 seconds ago, and now it's fixed. I'll have to go back and watch it. I mean, didn't it look like there was still lines there? And then how come all of a sudden there's no lines now? Like, I didn't do anything. I guess, yeah, it looks 100% right. Yep, signs. I can see dig dug. There's centipede, the turn. Yep, the signs look good. Card looks good. So interesting. 2148. I'm gonna test those 2149s in my Neolock or something. I'm gonna test them and come back before I wrap the video up. But that's exciting. That's good, because I was just totally guessing. I was trying to do it the methodical way, not just shotgun stuff. But obviously one of those or both of those are not completely right. Very interesting. Alright, I have them in the Neolock, and both RAM test fine, so it might just be an age thing where they're not, they're just degrading and the timing isn't great or something.
Oh, okay. Well, that one tested bad. Why is that? It tested good last time. There you go. I don't know, man. It's got to be just a weird timing thing. They're just, you know, old enough where they needed to be replaced, those 2149s. Because it's still doing good. I got music in the background. I'm going to put this in the cabinet because actually I don't know if this board set fully works. We got everything fixed, but I haven't tested it in the cabinet. So I don't know if like gas and all the sounds work and all that stuff. So let me put it in the cabinet, play a game, hopefully. I almost forgot. I was swapping around the CPU boards and stuff like that. So anyway, I had to replace C55, I think, if I recall, and I still have this 9M with bad legs that I'll do that. I have one more pole position to fix, and I'll screw with that on that one. Right now I have a donor 9M in it. I put question marks by the ones that I thought had bad legs, but now obviously it seems that those are working fine. I assume. I don't know what those customs are for. We didn't dig into that, but this is both revision Bs, and you know, I'm not super happy with how I did that. I still need to like protect the copper over here, and I probably didn't need to do as much work on it as I did, but anyway, it's not bad. Obviously it's cleaned up, much better than what it was. All right, so it just reset. So there could be some gremlins in this thing. See, it's resetting a little bit, which is a little weird, and that could be from this board here. I'm not sure, but I'm going to put it in the cabinet, let it run for a while, and play a game. See if anything. Oh, you know what else? I did get some Z8002s in the mail, and so I need to replace those as well. Actually, I might put both the new ones in here real quick, because this one goes with another Poland. Game. Some UB8002s. Game works fine. All right, so let's go put this in the cabinet. Back at the cabinet. I only have about 4 minutes, but this is the board right there. These are the board sets I just fixed. RevB with that one ROM. That's the older ROM. It's a 131. And so let's see, turn off the lights. Let's hope it works. Let's listen to that crash sound, hopefully. Oh boy. That's not good. Alright, we're good. I reseated the edge connector, the rear one. Alright, let's play this thing. See if it works. Or if we notice anything wrong. Oh, we got some prepare to qualifies jacked up. Oh my god. Alright, just reset. So we might still have some other issues here, obviously. It doesn't like being in the cabinet. I don't know, I power cycled it. Oh, it just reset again. What the hell is going on? It was fine on the bench. Oh shit. Maybe this thing's not over. Check it out, I got the lines back again. I've just messed with it for like 2 seconds, but now the line's back. Is it that RAM? Yeah, something is not happy here. Damn, I thought this was going to be a finishing part. Those lines are back, so it can't be the RAM. If I put it in test mode,
qualified. Post driving qualified to vote.
Yeah, so I think all the switches are working. Weird. I don't know what else is going on here. Let's see if it locks up again. Yeah, that I got another issue. It seems like we got some other issues going on. And it's got to be on the video board. And it's not that RAM. And you know what? I threw away that old RAM. I thought that was the problem. Crazy. What a pain in the ass. There we go. Well, I'm going to publish this video. We'll have to come back and mess with this.